Hello and welcome to K2P classes. In this class, we are going to study polynomials. Remember, the lighter you become, the higher you fly. But the question is, how do you become lighter? The answer is simple. Just throw out your ego, throw out your anger, throw out your greed, throw out your fear. Once you remove these things from your life, you start feeling lighter, and I am sure you will fly higher. In this class we are going to study 1. Introduction to polynomials. 2. Zeros of a polynomial. 3. Relationship between zeros and coefficients of quadratic polynomials. 4. Statement and simple problems on division algorithm for polynomials with real coefficients. 4.1. Dividing a polynomial by a monomial. 4.2. Dividing a polynomial by a polynomial, long method. 4.3. Dividing a polynomial by a polynomial, synthetic division.
Now, question is, what is a polynomial? An expression of a number, a variable with whole number exponents, or the product of a number and one or more variables with whole number exponents or their sum is called polynomial. Examples. See, 2. 2 is a number. X is a variable. X cube. It is a variable with whole number exponent. X into y. It is the product of two variables. Here it is their sum, x square plus 5x plus 3. Type of polynomials. Monomials are polynomials with exactly one term. Example 2x, x cubed, xy, x square y cubed, 3x, 3x to the power 6 y square. Here we see that none of the terms have any plus or minus sign. So any polynomial having no plus or minus sign is a monomial. Binomials. A polynomials with exactly two terms is called binomial. Here 2 plus x, x cube minus xy, x square y cube plus 3x. So if you see here, there is exactly one plus or minus in the expressions. These are binomial. Bi means 2. So it has exactly two terms. And what is a term? Terms is any constant or variable or with whole number or their product. Trinomials or polynomials with exactly three terms. So these are the examples of trinomials. You can see that there is exactly three terms. In another word, there are 2 plus or minus or their combination in the expressions. Coefficient. The number in front of a variable is called coefficients. Like in 3x, 3 is the coefficient of x. Degree of monomials. The sum of the exponents of all the variables in the monomials is called degree of monomials. Example, in monomial 3x to the power 6, y to the power 2, degree of monomial is, yes, you have correctly guessed, it is 8. Degree of polynomials. The highest degree of terms. Example, in polynomial 3x to the power 4, y to the power 2, plus x to the power 2 y to the power 3 plus x plus 2. So the degree of first term is 6, second term is 5, third term is 1, and the fourth term is 0. Which one is the maximum? You are absolutely thinking in the right direction. It is 6. A polynomial with a degree of 1 is called linear. A polynomial with degree 2 is called quadratic, and with a degree of 3 is called cubic. Example, x plus 2. What is this? Is it linear? Just guess. Quadratic? Cubic? Try to guess it. Then x square plus 5x plus 3, or xy plus x plus 3. X cube plus x square plus 2x plus 3, or xyz. The first one is linear. Why? Because the degree of the polynomial is linear, because the degree of the polynomial is 1. Here the degree of the polynomial is 2, because the highest degree of any term is 2. Here it is xy. So x to the power 1, y to the power 1. The sum of xy is 2. Quadratic. So that is why these are quadratic polynomial. Here the degree of the polynomial is cubic. Why? X cube. The highest one is x cube. Or here xyz. X into y into z. So x to the power 1, y to the power 1, z to the power 1, 1 plus 1, 2 plus 1, 3. So it is cubic. Polynomial in one variable. As from the name, it's very clear that in this type of the polynomial, there will be only one variable. If each term of a polynomial contains only one variable, it is called polynomial in one variable. Example, x, y cube, 3z, 8x plus 6, x square plus 5x plus 3. See the last one. Although there are 3 terms, but the whole expression contains only one variable, that is x. A standard form of a polynomial. In a standard form, terms are in descending order of their degree, and the coefficient of the first term is always positive. Let us see. Example, standard form a polynomial. 5x plus 4x to the power 4 minus x square minus 7. This is a polynomial, but this is not in the standard form. Why? Because the terms are not in the decreasing order of their degree. Let us rearrange it. Why? But we are writing 4x to the power 4 first, because this term have highest degree. And what is degree? Degree is the sum of power of all the variables. So here it is 4. Since it is the linear, since it is polynomial in one variable, so only x is here. What is the second one? Yes, this term had, after this is the highest, this term are having highest degree. So this is the standard form of the polynomial. Let us see another example. 2x cube minus x to the power 4 minus 7 plus 5x plus 5x square. You can see it is not in the standard form. So let us rearrange it to make it in a standard form. Is it okay? Is it in the standard form? I think no. because the leading term cannot have negative number. So take -1 as common, then just multiply by -1 entire expression, and the first expression will have positive coefficients. Now this is in the standard form. So we have completed introduction to polynomial. Now, zero of polynomial. Zeros of polynomials means the value or values of variables for which polynomial value is 0 is called a zero of the polynomial. In another word, if px is a polynomial and for x equal to k, that is pk is 0, then k is called a zero of polynomial. Example, if polynomial is 2x minus 4, then if we put x equal to 2, the expression becomes 0. So x equal to 2 means 2 is 0 of 2x minus 4. Let us take another example. X square minus 3x plus 4. Here we see that if we put -1 in this expression, the expression becomes 0. And if we put 4, then also this expression becomes 0. That means -1 and 4 are zeros of polynomial x square minus 3x plus 4. The geometric meaning of zeros of polynomial. Let us see here. This is the graph of y equal to x plus b type of equation. This is the linear equations, and the linear equation always represents a straight line. That I will teach you in some other class, but for the time being, just understand that if you draw y equal to x plus b, this will be a straight line, and it will cut x-axis at any one point, and that is why this equation, linear equations, will have only one zero. Like here, 2x minus 4, the zero of this expression is 2. Take quadratic expression, quadratic polynomial. So graph of the quadratic polynomial will be this type, u, or reverse u. So we see that here the graph cuts x-axis at 2 points. So for all the quadratic polynomials, there may be 2 zeros. There may be only 1 zero, and in that case this curve touches the x-axis, not cuts the x-axis. Now, relationship between zeros and coefficient of quadratic polynomial. Let alpha and beta are two zeros of quadratic polynomial, ax square plus bx plus c. That means if you put either alpha or beta in these expressions, the value of the expression becomes 0. So x square plus bx plus c can be written as ax minus alpha into x minus beta, that is ax square minus x alpha plus beta plus alpha into beta. That means the expressions can be written as ax square minus alpha plus beta into x into alpha into beta. So equating coefficient of x, we get b equal to minus a alpha plus beta. So alpha plus beta equal to minus b by a. That means sum of two zeros of a quadratic polynomials is minus b by a, equating constant term, that is c is equal to a into alpha into beta. So alpha into beta equal to c by a. Guru mantra. For any quadratic polynomials, sum of zeros equal to minus coefficient of x, that is minus b, by a, that is coefficient of x square, and product of 0 is constant term divided by coefficient of x square, that is c by a. Let us consider a quadratic polynomial in single variable x as below: 15x square minus 5x plus 3. Then what is the value of sum of zeros? From here, the sum of zeros is minus b by a. Here b is minus 5 and a is 15. So it will be minus 5 by 15. 5 by 15, that is 1 by 3. Product of zeros, that is c by a. What is c? C is the constant term, and what is a? A is the coefficient of x square. So product of zeros equal to 3 by 15, that is 1 by 5. Now we will see statement and simple problems on division algorithm for polynomials with real coefficients. So dividing a polynomial by a monomial. Six r square x square by 3 rx square minus 9 r square x s by 3 rs. This is a very simple one. In this given problem, just do these operations. So 3 rs will divide each terms, each numerators, and this will be 3 rs plus s minus 3r answer. The second one, 3a square b plus 6a cube b square plus 18ab by 3ab. Again, we will apply same methodology. And the answer will be a plus 2a square b plus 6. Same. Answer is 4y minus 1. So, if in denominator it is only one term, then this methodology will work. But if it is more than one term, then we have to apply different methodology. Dividing a polynomial by a polynomial. Previously we were dividing a polynomial with a monomial, means only one term. Here the numerator is a polynomial. So the method is just draw a horizontal line and then vertical line like this, and put numerator under the horizontal line and the denominator this side, left hand side of vertical line. So see here, this is x to the power 1, here it is x cube, and here the coefficient is 5. So you have to multiply this by 5x square to just get 5x cube. So our objective is to get the first term here. So it is 5x square. If you multiply with this, it is 5x cube minus 10x square. A simple division. Then we change the sign here for subtraction, and then this will cut each other. And minus 3x square minus 13x square plus 10x square is minus 3x square. This 10x will come here. Again, see here, it is minus 3x square. So how to get minus 3x square? You have to multiply by minus 3 into x here. So second time it is minus 3x. So 3x square plus 6x. This minus is 6x. Now again we subtract and we get 4x. Then 4x, this 8 will come here. So this time to get 4x we have to multiply here by 4. This time the remainder is 0. So we can say 5x cube minus 13x square plus 10x minus 8 equal to 5x square minus 3x plus 4 into x minus 2. Let us see another example. Evaluate x to the power 4 plus x square plus 1 by x plus 1. We will start dividing here. So it is x to the power 4. So we get here by observing, we can guess that we have to multiply it by x cube to get x to the power 4. So now to get here x3, we have to multiply here minus x square, right? And this will come here. So then we multiply by x square minus x square. We get minus x cube minus x square. This will cancel out each other. 2x square. This 0x will come this side here. And just to get 2x square, we have to multiply this by 2x. We will get 2x square plus 2x minus 2x plus 1. So to get minus 2x here, we have to multiply here by minus 2. So 3 is the remainder here. So we can say that x plus 1 will not totally divide x4 plus x cube plus 1. So we can say that x to the power 4 plus x square plus 1 can be written as x cube minus x square plus 2x minus 2 plus 3 by x plus 1. It is like any ordinary division of numbers. Now the same thing we will do in a synthetic method. Here we have to divide 3x cube minus 4x square plus 2x minus 1 by x plus 1. So we have to draw like this. We have to put all the coefficients here, 3, minus 4, 2, and the constant should be this side, minus 1. And then opposite of number in divisor. The divisor is x plus 1. So what is the x plus 1 means what is the opposite? It will be minus 1. Suppose it is x minus 2, then it will be 2 here. Then write down 3 here. So if you multiply minus 1 to 3, first you have to just copy this first from here, then with this minus 1, 3, it becomes minus 3 here. Add minus 7. Then again minus 1 with minus 7, it is plus 7. Add this to 9 here. Then minus 1, 9. Minus 1, and minus 9 here. Then minus 10. And 3 x square. Just one less power. It was here x cube, so it becomes x square. 3x square minus 7x, one less than this, and then 9, and the remainder is minus 10. Let us take another example. No, I am not taking another example. I am just dividing this by long method. See what happens, and at the end we will see the two answers are same. So multiply 3x square because we want 3x cube here. Then subtract this 3x square plus x, 3x cube plus 3x square plus 1, 3x square. This will cancel. Minus 4 minus 3x square, 7x square. This will come here, 2x. Then to get here minus 7x square, x should be multiplied with minus 7x. Minus 7x. Then minus 7x into 1 is minus 7x. Subtract, change the sign. We cancel out here. 9x. And this 1 will come here. To get 9x here, we have to multiply here by 9. So here again remainder is 10. Look. Same answer. 3x square minus 7x plus 9. 3x square minus 7x plus 9. Right? The remainder is 10. So this shows that both methods give the same results. This is the long method and this is the synthetic division methods. So this will take less time. So in exam, you can follow any one method unless or until the method name is not specified. Thank you very much. For any clarification, write us on k2pclasses@gmail.com or call us on +91 943 111 7966. Thank you.